Hello guys, welcome to week 4 tutorial for Psychrometric chart part 1. So in this tutorial we are going to talk about psychrometric chart. Part of it is just the theoretical calculation, and then the final parts of this tutorial are the psychrometric charts method. Okay. They are very easy. I think you have seen this before in your thermodynamics class. And let's go. Without further ado, let's go to our tutorial for psychrometric chart part 1. Usual, I would like you guys to first drop by our times page and then scroll downwards to our tutorial section. You need a few files or documents which are all available on Times. First of all, you need to open this file, psychrometric chart, this one. So open this and put this on a new tab. Okay, so I have it already in my PDF annotation app, the PDF expert. So open this one, and then you need to open this table A1. A and B is for the SI unit and also the English unit, and then you need to open the tutorial 4, right? Open tutorial 4 there, and of course open the tutorial 4 answer. So have all these 4 documents in somewhere that you can edit, you can annotate, or whichever you like, however you want to do it. Okay, so let's go to my PDF. Okay, so I have all the files here which I'm going to use today. These are the questions. We have 1, 2, 3, 4, 5 and 6 questions. Some of them are calculation based and some of them are psychrometric chart based methods. Okay, so let's go to this one. So I am going to use let's say a blue pen here. Let's go for our first question. The first question says, a space at temperature 74 degrees Fahrenheit or 24 degrees Celsius, relative humidity of 45% is contained. Find A, the partial pressure of air and also the water vapor, B, the vapor density, and C, the humidity ratio of this mixture. Assume standard sea level. Okay. Now, first of all, notice that it used the word assume standard level, standard sea level. That means you can use the psychrometric chart which is available that we have downloaded just now. Okay, the first one, it asks you to find the partial pressure of air and water vapor. Now, the equations are available on your slides. Okay, for example, go to your relative humidity section on the notes, and you will see that the equation is phi is equals to PV over PS. Right? It's too thick. PV over PS. This is vapor, and this is for saturated vapor, saturated pressure. Okay, so by rearranging an algebra, you have your PV is equals to phi times PS. Okay, phi is already given. Phi is the relative humidity, which is 45%, right? And then PS 3.17 comes from the table. So if we go back to this table now, note that the numbers are 75 degrees Fahrenheit or 24 degrees Celsius. So here is the table A1, A and B. So the first one is the English unit, right? English unit, and the second one is in SI unit. Since our question is in the you can set either English or SI. Here I go first for SI unit. So go for SI unit and go for 24 degrees Celsius. Now as you can see, we don't have 24 degrees Celsius, right? You can do interpolation, or somehow in aircon you can do approximation. So our degrees was 24 degrees Celsius, which is close to 25. Now what you will do is you can state on your answer script in the exam that the temperature, maybe you can approximate it to be 25 degrees Celsius, and by that you can take 0.00317 megapascal, which in turns divide by 1000, right? 0.00317 divided by 1000, times 0.00317 times 1000, and you will get 3.17 pascal. That is what you get here, 3.17 pascal. Alright, okay, so you times that, and this is your PV. PV is a P vapor. Now you can also use the English unit, and you will find out that the PSI is 0.196 PSIA. Okay, so to find PA, the equation was P is always a partial pressure. I think it's Dalton. PV plus PA. So you rearrange this equation. PA will be your unknown, and your P is 101, which is the standard sea level, right? And then you minus with 1.43, and then you will get, this is your PA. Also you can do the English unit. You get 14.5 PSIA. So that is your partial pressure of water and vapor. Now for the density, the density part is quite interesting. So you can find the equation online, right? But we don't have any density given in this equation. You can use the ideal gas and get your density from there. Okay, so what you have is actually let me write it down. P V N R T, right? Where N is your P V, M for mass, R T divided by big M, molar mass. So let me change the color. Alright, so by rearranging that equation, you will get P M over V R T. Okay, PV M, like this, sorry. So what you have, M over V is also density. So what you have here is rho R T over M. Okay, rho R T over M. So rearrange that. So since you don't, this molar mass, what is the molar mass of this case? The molar mass of this case is almost infinity. Why? Because you don't specify a state or the mass of the air that is encompasses that space. The mass of air can be indefinite. So you can make it like this. This is indefinite. Indefinite. So you can disregard it, and whatever left was or are similar to this. Okay, so I hope you know how this equation is obtained, right? And it's not unobtainium, it is obtainium. Okay, so that is how you get that equation. So rearrange that, so you don't have the density, but you have the P, right? P is calculated, which is this one. PV is calculated, right? And your R should be given, which is not given there. So R will be given, which is this one, 462.5. And then the temperature is 24 degrees Celsius, and change it to Kelvin. This is R. So what you have there is 0.0104 kilogram per meter cube. Or you can do it in your SIU English unit. You get 0.0062 pound vapor per feet cube. Number 2, you need to find the relative humidity. Is given by in your notes. It is let me check my notes first. Given by 0.622 PV over PA. But you can also use this, it depends, I'll give the equation later. So PV is already calculated above, which is 1.43, and PA also calculated at 99.57. So put in these numbers and you get 0.00893 kilogram of vapor for each 1 kilogram of air, or in the English unit 0.00854 pound vapor per 1 pound of air. Now the second question is determine the humidity ratio, enthalpy, specific volume for stratosphere air at 1 standard atmospheric pressure using perfect gas relation for temperature 80 degrees Fahrenheit or 27 degrees C. First of all, you must know what is our P total or P atmospheric pressure for English unit. For SI unit, it is 101 kilopascal, more or less. However, in English unit, it is 14.696 psi. So in this case, we need to find PV, which is available on the table. Go to the table, and at 80 degrees Fahrenheit, it is 0.507 psia. Or what is in English unit just now? SI unit, 27 degrees C. 27 degrees C, you have to find using interpolation, and you cannot approximate it because 27 is far from 25 and also far from 30. Now in this case, I'm using the simplest one for my tutorial, 0.507. Let's go back to our question. Alright, so what you need to do is I'm just going to plug this in. W is equal to 0.6219 PV over PA, right? So PA is unknown, so you need to calculate. So we all know just now that P is PV plus PA, right? So we just put in minus P minus PV as given here, right? And then you get your answer 0.0222 pound volume for each 1 pound of air. Next, to find the enthalpy. Enthalpy is in the it's in the notes. So if I can open the notes here, and let's go to enthalpy, and you find the equation for both SI and English unit. So of course, I'm going to take the English unit, which is this one, right? And let's go back to our answer. There it is. So we have our temperature 80 degrees Fahrenheit. We have the specific relative humidity. We also have again the temperature. So put in all this and you get your answer is 43.55 BTU per pound mass. Right? Last is the specific volume. Yes, specific volume. You can use the ideal gas equation and change to that volume into specific volume, right? Since you don't really have or you can do this m over v, right? M over v. Yeah, you can give a specific volume. So the equation, you change it and you have R, which is will be given, and this is your T, change it to Rankine. So PA is this, 14.696 minus 0.507, that is for to find PA, and times 144, which is the equivalence of pound, what is it again, equivalent to volume, to change it from to feet cube, which has been discussed in the previous tutorial. Now this one, question 3, is for us to find from the psychrometric chart. So now on my other phone, I'll open the psychrometric chart, the answer, which is this one. Okay, so the question is, moist air exit at 100 degrees Fahrenheit dry bulb temperature, 65 degrees Fahrenheit thermodynamic wet bulb temperature, and you have it in 14.696 psia or 29.921 in mercury height. So it tells you to use the psychrometric chart for English unit. Determine the humidity ratio, enthalpy, and dew point temperature, and also relative humidity, and also specific volume, which all can be done using the psychrometric chart, which I have it here. So on this chart, I have the SI unit and also the English unit. So the first one is the English unit. Okay, so the solution is find your dry bulb first at 100 degrees, change it to 0.5 and black, which is this one. Oh, it's too small. Okay, alright, that is 100 dry bulb temperature. Next, you need to find the 65 degree wet bulb temperature. So the wet bulb temperature is given by this slanting line, as you can see there. Right, let me clear that up, and it is at 65, which is this line. Okay, so what you have is a cross at that point. Now the first is to find the humidity ratio. Let me take a green line. It's a horizontal line to this way. So let me be as accurate as possible. Right? Okay, so you can use your ruler and you can use your distance. For example, from here to here, what is the distance on your ruler? And from here to here, what is the distance? So the differentiation by using the ruler, you can get pretty much what is the answer. And given on the answer script is, let's go back to the answer script. (0.00523 pound water over pound of dry air. Okay, that's number 1, which is the humidity ratio. Now next we need to find the enthalpy. Enthalpy is this line, right? Enthalpy. Now I myself wouldn't mind to get the enthalpy at 30 BTU per pound of dry air, but if you take a look at the answer there on your script, it is 29.8 by nearest age scale, but I don't mind. Myself, I would take 30 BTU per pound of dry air. The dew point temperature is given by, let's see, that's wet bulb. Where is the dew point temperature? The dew point temperature is given to by a horizontal line to the left. So if I can be as accurate as possible, there, the answer will be around 40 degrees Fahrenheit. Yes, 40 degrees Fahrenheit. Next, the relative humidity, which is given by this curvy line here. So the curvy line, it is between 10 and 20 degrees, 20%, you can use the difference on your ruler and find what is that X marks that spot, or you can just, okay, I'll take it as 15 or 13 degrees, 13 percentage, but you can use ruler to be very exact. Okay, lastly, the specific value, which is given by these lines. Okay, that line, which is between 14 and 14.5, and you use your ruler again from this distance to this distance and this distance. What is the difference between that two? And the answer on your answer script there is 14.22 feet cube per pound of dry air. Alright, that is how you find using psychrometric chart. Okay, that's one is done. Question 4. Question 4 is using the same method, but now we are using the SI unit. Moist air exit at 40 degrees dry bulb temperature and 20 degrees thermodynamic wet bulb temperature. And this is our atmospheric pressure of 1 atm or 101.325 kilopascal. Determine the humidity ratio, enthalpy, dew point temperature, relative humidity, and specific volume. Now, let's go back to our chart and scroll to the SI unit. On my other device, I have the answer. So locate that state point where it is 40 degrees Celsius dry bulb, which is there, right? And crisscross it with 20 degrees of wet bulb temperature. Our wet bulb is that dotted line. That dotted line, which is this, right? That dotted line. And we go to 20 degrees. This is 25. This is 20. So if I take a green line up to that point, there, this is our X marks the spot. Okay, so the wet bulb temperature, or the relative humidity ratio is to the right. Okay, this way, it's between 6 and 8, right? You can use your ruler, find the differentiation of distance, and you will get around 6.5 gram of water over 1 kilogram of dry air. Okay, enthalpy is these lines. So this line is enthalpy. So on the answer there is 56.7 kilojoule per kilogram of dry air. You can use your ruler to find the distance between this and this. Okay, this and that. And next, we need to find the dew point temperature, which brings you to the right side of this. Oh, sorry, it's too high. Right, on the answer script, I have it to be 7 degrees Celsius. So you can use your ruler or approximate it by 5, 6, 7, 8, 9, 10 degrees Celsius. Right, I can bring it down. You can bring it down as well. 5, 6. Oh, sorry, I don't think so. That one is the dry bulb temperature. So this is the temperature for saturation or dew point. Relative humidity is this line. Relative humidity is this curvy line, which is between 10 and 20%. So on my answer there, I put 14%. Find the distances, and the specific volume will be this line, right? So it is between 0.9 there and 0.88 there. So that between there, it is should be just 0.89, but it's a little bit above, so it will be around 0.896 as shown in the answer script. Okay, very easy. What do you need to do with these numbers? Of course, in the future, you need to put this in your cooling loads. Let's go for question 5. So we have the, let's increase to 2 points and blue. We have the approximated psychrometric chart there, so I'm going to use there, and you compare it with your answers later. Yeah. Okay. Moist air at 85 degrees Fahrenheit, dry bulb temperature, and 50% RH enters a cooling coil. So you have a pipeline, there's a cooling coil, air enters and air exits. So the entrance is 85 degrees Fahrenheit and 50% RH enters a cooling coil with a speed of the volumetric flow rate of 10,000 cubic feet per minute, and is processed to a final saturation of 50 degrees Fahrenheit. Find the tons of refrigeration required. So it says here, figure 5, which is that figure, shows a schematic solution. State 1 is located there, and state 2 is located there, by using the states which is given here. Okay. So let's read. T is 85 degrees Fahrenheit, 50% RH. Therefore, H1 or enthalpy is 34.62 BTU per pound of dry air. The relative humidity is 0.0129 pound of water over pound of 1 pound of dry air. Specific volume is 14.01 feet cube per 1 pound of dry air. State 2 is located by using the saturation curve, which means it reaches 100% of relative humidity at 50 degrees Fahrenheit, and H2 is 20.3 BTU per pound of dry air. Omega, or the relative humidity, is 0.00766 pound of water over pound of dry air, and from table 3, H water 2 is 18.07, which is from this table at 50 degrees Fahrenheit, right? 50 degrees Fahrenheit. Let me go back, I forgot. Short-term loss, H. There, 18.1. Okay, so over there is 18.1, but on the answer is 18.07. Doesn't matter, you can write it approximation of 18.1. Maybe the answer will be a bit different, but I will have the range of answers on the answer script, so that anyone who marked your paper will be taking it correct. So M dot is V dot over 14.01. Okay, this is an equation for mass flow rate given by volumetric flow rate divided by okay, you figure it out. What is 14.01? Okay, the answer is 713.8 pound of dry air over minute. So the equation 45, which is taken from the textbook, right? That's from textbook. That means from our slide, I think you go back to enthalpy and use the one for English unit, and you put all the answers there, which is this one, right? Now all the answers there, and you have around 10.154 BTU per minute, or you can change it to tons of refrigeration using the conversion, 50.77 tons of refrigeration. Now, question 6, the last one. Moist air at 30 degrees dry bulb temperature, 50% RH enters a cooling coil at this speed, volumetric flow rate. Now this is SI unit, 5 meter cube per second, and is processed to final saturation at 100% RH, and it is cooled down to 10 degrees Celsius. Find the kilowatt of refrigeration required. So that is your cooling load for SI. So again, simply find state 1 and state 2 using a psychrometric chart, and you get all this data. Again, similarly, this is your volumetric flow rate, and then you put in the equation for Q. You can also find this on the lecture notes for SI unit, and the cooling load in SI units around 197 kilowatts. And that concludes our week 4 tutorial for psychrometric chart part 1. As I say, it's quite easy. There are just a few tables to check before we proceed with calculation or with any decision for the cooling loads, both SI and English unit. So that is for this week. I will see you next week in week 5, the same one, psychrometric chart part 2. Okay? Bye.